Assalamu alaikum. We started our topic about inflation. We are now going to continue. We talk about the quantity equation and its different variables, and how the money supply and the growth of the money supply in the economy affects the increasing of the prices or the change in the prices. And we see the logic behind this equation, and how the money supply growth affects the prices growth and the inflation rate growth. Now we are going to talk about the inflation and the interest rates. As we know, the nominal interest rate, which is denoted by I, is the interest rate that is not adjusted for inflation, and the real interest rate, which is denoted by R, adjusted for inflation. So the R, or the real interest rate, equals the nominal interest rate minus the inflation rate. Again, the real interest rate equals the nominal interest rate minus the inflation rate. So the Fisher effect, that takes us to the Fisher effect, or the Fisher equation, that rearranged the equation of the real interest rate, that the nominal interest rate should equal the real interest rate plus the inflation rate. So as we know that the real interest rate is determined by the savings and the investments, as we see in chapter 3. Hence, the increase in the inflation rate causes an equal increase in the nominal interest rate, as we can see from the Fisher equation. So this one-for-one relationship is called a Fisher effect. When the inflation rate increases, the nominal interest rate should increase. So the Fisher effect, we have to notice that the Fisher effect doesn't imply that the nominal interest rate equals the inflation rate, but it implies that the changes in the nominal interest rate equal the changes in the inflation rate. So again, not the nominal interest rate equals the inflation rate. No, they are totally different. But the changes that happen to the inflation rate will equal the changes in the nominal interest rate. And as we know, the value of the real interest rate is constant, because it is determined by the equilibrium between the savings and the investments. As you can see in this example, if you have a deposit or a loan by 1,000 with a percent interest rate of 5%, and then you will buy an refrigerator, for example, with the inflation rate 6%. So we can see the difference that happens between the interest rate and the inflation rate will make the value of the money that you hold are less valuable. So now we can see that the real interest rate, if it is 5%, and the inflation rate, or the expected inflation rate, will be 10%. So the nominal interest rate should be 15%, according to the Fisher effect. So the nominal interest rate 15%, it is the real interest rate 5% plus the expected inflation rate, the 10%. So as the expected inflation rate rises, as you see here, from 10% to 14%, for example, so the nominal interest rate, also the change in the nominal interest rate, will rise as the change in the inflation rate. As we can see here, the nominal interest rate, the changes in the nominal interest rate and the inflation rate are together, as the data are consistent with the Fisher effect, as we see in this chart. The inflation and the nominal interest rate are very highly correlated. However, they are not perfectly correlated, which absolutely doesn't invalidate in the Fisher effect. But over time, the saving and the investment curves move around, causing the real interest rate to move, which in turn causes the nominal interest rate to change for a given value of inflation. As we see here also, the inflation and the nominal interest rates across countries. We can see the nominal interest rate percentage in the vertical axis and the inflation rate in the horizontal axis. And in different countries, we can see a linear relationship and positive, strong relation between the increase in the inflation rate and the increase in the the nominal interest rate, which is an evidence for the Fisher effect in the real. Okay, now let's take an exercise. Suppose V is constant, as the theory of the quantity equation assumes. Money supply is growing 5% per year. The quantity of output is growing 2% per year, and the real interest rate is 4. We need to find the nominal interest rate. Sorry. Then, if the central bank increases the money supply or money growth, rate by 2% point per year, find the change in the nominal interest rate. What will happen to the nominal interest rate if the money supply increased by 2%? Then suppose the growth rate of the quantity of output falls by 1% per year. We need to know what will happen to the inflation rate, and then what must the central bank do if it wishes to keep the inflation constant. Okay, try to pause the video and think about these questions and solve them, and then get back and check your answers. Now we're going to see the answers of this exercise. First, we have this information about the money supply growing is 5% per year, the output grows 2% per year, and the real interest rate is 4. So to find the nominal interest rate, we have first to find the inflation rate. According to this information, the inflation rate is the money supply growth, which is 5, minus the total output growth, which is 2%. So 5 minus 2 will equal 3. The inflation rate will be 3, according to the inflation rate equation that we see in the previous lesson. Then, according to the inflation rate, we'll find the nominal interest rate, which is according to the Fisher effect, or the Fisher equation, the real interest rate, which is 4, plus the inflation rate that we found now, which is 3. So the nominal interest rate will be 7. Next, we want to find the change in the nominal interest rate. Sorry, if the central bank increased the money growth rate by 2%, what will be the new change, or the change in the nominal interest rate? We need to find the new interest rate, nominal interest rate, to find the change in it. So the money growth was 5%. In this case, if it's increased by 2%, it will be 7. So the inflation rate will be 7 minus 2, so it will be 5, and the nominal interest rate will be 4 plus 5, so it will be 9 instead of 7. So the change in the nominal interest rate will equal 2. So it is the same as the increase in the money growth rate. As we see in the question, it's supposed that the money supply increased by 2%. So we find that the change also in the nominal interest rate will be 2, which is the same as the increase in the money growth rate. The third question was, suppose that the growth rate of Y falls by 1% per year. If the growth rate of the output falls by 1%, what will happen to the inflation rate? So the growth rate is 2%, as we see. So what will happen? The inflation rate, it will be 5 minus 1 instead of 2, because the growth rate will fall by 1, so it will be 1% instead of 2%. So the inflation rate will be 4. 5 minus 1, so it will be 4. So the change between 4 and 3, it will be 1. The change in the inflation rate will be 1. And to prevent the inflation from rising, the central bank must reduce the money growth rate by 1% per point per year. Okay, so now we have two real interest rates. The inflation rate, which is the actual inflation rate, which is not known until after it has occurred. The actual inflation rate. And now we have the expected inflation rate. The expected inflation rate. We have the ex ante real interest rate and the ex post real interest rate. Ex ante means before and ex post means after. So we have two kinds of real interest rates. If the nominal interest rate minus the inflation rate, the actual inflation rate, and the nominal interest rate minus the expected inflation rate. In the first case, if the nominal interest rate minus the expected, what is the inflation rate will be in the now we expect what will be the inflation rate. So the real interest rate people expect at the time they buy a bond or take out a loan. You are buying a bond now or taking a loan, and you expect the real interest rate what will be. The nominal interest rate minus the actual inflation rate, the real rate interest rate actually realized after this period of 1 year or 3 years passed. So this is what is the actual, the real interest rate which actually realized by us. Now let's move to the money demand and the nominal interest rate. The money demand. Imagine that a consumer has a certain amount of wealth, which is divided between money and other assets. You have liquid money and you have any other assets like bonds or so on. So the other assets typically generate some type of income, like interest income in case of bonds and so, but are much less liquid than money. Okay, so there is therefore a trade-off. The more money the consumer holds in his portfolio, the more income he forgoes, and the less money he holds, the more interest income he makes, but the less liquid is his portfolio. So there is a trade-off. So with this background, a consumer money demand, what we mean by money demand, the consumer's money demand refers to the fraction of his wealth he would like to hold in the form of money. Again, the money demand of a consumer refers to the fraction of his wealth he would like to hold in the form of money, as opposed to less liquid income generating assets like bonds. So this is the money demand. Why we know this? In the quantity theory of money, the demand for real money balances depends only on the real income. So another determinant for money demand, the nominal interest rate. How the opportunity cost of holding money, money instead of bonds or other interest earning assets. So hence the nominal interest rate increase, the money demand decrease. Why? Because the money demand is the amount of money you hold. So if the nominal interest rate increases, you will put this money in other interest earning assets instead of holding this money. So this is the relationship between the money demand or the amount of money you hold and the nominal interest rate. As you see from this is the money demand function. So the real money demand depends negatively. The real money demand, the money you want, negatively depends on the nominal interest rate. And the nominal interest rate is the opportunity cost of holding money, as we said, and it depends positively on the income. The higher your income, the more you're spending, so the more you need money and demand money and hold money. Why we use L here for this function? Because L is used for liquid. L for liquid because it is used for money demand function because money is the most liquid asset. So an increase in the nominal interest rate represents the increase in the opportunity cost of holding money rather than bonds, and would motivate the typical consumer to hold less of his wealth in the form of money and more in the form of bonds or any other interest earning assets. So an increase in the real income, other things equal, causes an increase in the consumer's consumption and therefore spending. To facilitate this extra spending, the consumer will require more money. Thus, the consumer would like a larger fraction of his wealth to be in the form of money rather than bonds. This might involve redeeming some of his bonds, or it might simply involve holding the additional income in the form of money rather than putting it into bonds. So this is the relation between the income and the money demand and the interest rate and the money demand. In the case, as we said, in the case of the negative relationship between the nominal interest rate and the positive interest rate between the income and the money demand. So we can see the link between the money demand supply that is determined by the central banks and the money demand. We can see here the money supply determines the price level and then the inflation rate, and so the nominal interest rate, which is determine the money demand. So the linkage among money and prices and interest rate. This figure can illustrate the relationships among money and prices and interest rates, as the money supply and money demand determines the price level. So changes in the price level determine the inflation rate, and the inflation rate influences the nominal interest rate because the nominal interest rate is the cost of holding money. It may affect money demand. So this last link in the blue line is omitted from basic quantity theory of money. So when people are deciding whether to hold money or rather to hold bonds, they don't know what inflation will turn out to be. So hence the nominal interest rate relevant for money demand, which is the real interest rate plus the expected inflation rate. We can see here the instead of rearranging this function, the real interest rate plus the expected inflation rate instead of the nominal interest rate. So we can reach the equilibrium. So the supply of the real money balances will equal the real money demand. So we can find the equilibrium between the money supply and the money demand. So this, according to this function, the variables here in the long run, we can find the money supply, which is determined by the central banks, the real interest rates, which adjusts to make the equilibrium between the savings and investments, and also the output, which is the function of the factors of production according to the production function, the capital, the labor, and the technological development, and also the prices adjusted to make the real money balances to equal the money demand for given values for the real interest rate and output and the expected inflation. We can see how the prices respond to the change in the money supply. A change in the money supply causes price to change by the same percentage, just like in the quantity theory of money. According to this function. So what about the expected inflation? Over the long run, people don't consistently over or underestimate the inflation over the long run. So maybe the average will be the expected inflation equals the actual inflation rate on the average. But in the short run, the expected inflation rate may change when people get new information. For example, if the central bank announces that it will increase the money supply next year, so this means what? The people will expect the next year's prices to be higher, so the expected inflation rate will rise. So this affects the prices now, even if the money supply hasn't changed yet. So this is how the prices responds to the change in the money supply. But what about the change in the expected inflation rate? Also, for a given values of the real interest rate and output and the money supply, the expected inflation rate will increase. So the nominal interest rate increase according to the Fisher effect. And also the money demand will decrease because now the consumers will spend their money because it will be less valuable in the future. And also when the expected inflation increase, the prices increase to make the money demand fall to re-establish the equilibrium between the money demand and the money supply. So let's stop here for this limit about the inflation rate and the nominal interest and the relation between inflation rate and the nominal interest rate. And we will continue our chapter, inshallah, next lesson about the social costs of inflation and the hyperinflation and why governments make this inflation and so on. So see you inshallah next lesson. Goodbye and good luck.